Are you guys with me? We did, when we did Stoic problems, I started teaching it as a simple butterfly problem. Is that right? Was that right? You just set up your proportions, you draw the butterfly and you do that. I don't want my students using the butterfly method anymore. I switched to saying, okay, the monkey in the middle is a mole, and then you have particles on one side, and you have grams on the other side. Did I teach you setting up tracks? Did I do it this way? Did I say for grams you always get it from the periodic table, the number before mole is 1, and for particles it's 6.02 times 10 to the 23. Did we go through doing problems in this manner? Yes or no? So if you look at the first problem, I'm going from grams to what? To moles. Is that right? So I'm going from grams to mole. Do I always start with my given number? So it's 102.7 grams of potassium sulfate. Is that right? I need to get rid of grams. I need to get into moles. Is that right? And I go and find the molar mass from the periodic table. Is that right? Which substance's molar mass will I find out? Molar mass of 2 potassium, 1 sulfur and 4 oxygen added up. Is that correct? And I get that as 174.27 equals 1 mole. And if I solve this problem to correct significant figures, I get 5893 moles. Is that right? The grams cancel. Correct?
Yes.
If you look at the second problem, I'm going from moles to formula units. So where is it in this track? Where am I going? From moles to particles. Formula units are particles. Yes or no? So I always start with my 3.82 moles. I need to get out of my moles. I need to get into my particles, which are formula units, right? So mole is a 1, and my formula unit is 6.02 times 10 to the 23. Is that right? I did not need the formula mass of potassium nitrate in this case. And if I know to put numbers in a calculator, it is this many formula units of KNO3. Correct? Yes or no? The third problem, I'm going from grams, I'm going from formula units all the way to grams. Is that correct? Is it a two-step process? Yes or no? So, I am starting with my formula units. What do I convert my formula units into first? Into moles. And I cancel out of my particles. So what is my number before my particles? 6.02 times 10 to the 23 is 1 mole. But I'm not done with the problem because it's asking me to get out of moles and get into mass. And the given substance is barium sulfate. And so if I go and calculate the mass of barium sulfate, which is BaSO4, I get this set up. Is that right? And then my answer is 20.6 grams of barium sulfate. Are we good? Okay? So far, we only converted mass into moles or into formula units when we were given one single substance. Are you with me? This is very, very important that you understand this. We were only working with how many substances? 1. Now we're going to go from 1 substance to 2 substances. Alright? That is called stoichiometry. How do you connect or how do you find quantities of one substance that's made from another substance? Whether you give that as mass to me whether you give that as particles to me, whether you give that as moles to me, how will I find out how much of the other substance is being made? Okay? So in order to do that, we need to look at the ratio of the coefficients. The ratio of the coefficients is called what? It's called the mole coefficients. The coefficients are actually denote the number of moles of the substances that are participating. So how do I know how the moles are related? Am I looking at if you look at your balanced equation, it's K2SO4 plus BaNO3 twice, giving 2KNO3 plus BaSO4. Is that right? What are my coefficients? 1, 1, 2, and 1. The coefficients are my mole ratios. Is that understood? So in this case, if they ask me what is the ratio between potassium nitrate and barium sulfate, do I get the ratio to be 2 to 1? That is my mole ratio. What is my ratio between potassium sulfate and potassium nitrate? Is that 1 to 2? What is my ratio between barium nitrate and barium sulfate? Is it 1 to 1? What is my ratio between potassium nitrate and barium nitrate? It's 2 to 1. Again, most chemistry problems are ratio problems. We just need to know how to solve them. All right? So here is a relationship. It's relating potassium nitrate and potassium sulfate. So it's relating potassium nitrate and potassium sulfate. Do you see that? For every 2 moles of potassium nitrate, how many moles of potassium sulfate can you make? 1. But if you have, instead of 1, if you have 2.58 moles of potassium sulfate, how many moles of potassium nitrate can you make? Is it a simple ratio problem? But how do we set it up in chemistry? You can say 2.58 moles of potassium sulfate is what is being asked. Yes or no? What do I need to get rid of? Moles of potassium sulfate. So now I get rid of moles of potassium sulfate. What am I getting into? Which substance am I getting into? Moles of potassium nitrate. What is the ratio between these substances? What is the number before potassium sulfate? What is the number? 1. What is the number before potassium nitrate? 2. You just multiplied by 2, and that will give you how many moles of potassium nitrate, which is 5.16 moles of potassium nitrate. Are we good? Are we good? It was a very simple proportion problem. Yes or no? Okay. Let's get into the notes page now. Before the notes page, let me talk about the mole map. Do you have a blue colored mole map? Okay. Remember, I used to say monkey in the middle is a mole, and then I would say grams, and I would say particles. Who said that? Okay? Would I say that? Are you with me now? Instead of writing it on a horizontal line like that, what did I do? I made my mole in the center, and I'm talking about this as moles of A. What are the two things that flanked it? Grams of A. And what did I do with my particles? I brought it here. Does that make sense? I rewrote this like this. Are you with me? I still, from grams, I have to go to moles of A before I convert it to particles of A. Particles of A have to be converted to moles before I convert it to grams. Now I'm adding on to it. Are you with me? Not only do I have grams or moles of A, I can now switch to a different substance and go to moles of B. Now what is the only way I can connect substance A with substance B? I can only connect their mole ratios. And where do I get their mole ratios from? From the balance equation. I can give you particles of A, I can give you grams of A, and I can ask you any one of this about B. Is that right? What is important for me to do when I switch from substance A to substance B? Convert it into its. Convert it first, whatever is given, what should I have first? The moles of A. And then I will use my balanced equation. I will use the coefficients in my balanced equation to go from moles of A to moles of B. Is that right? And then I can switch into whatever of B is being asked. This is in all stoichiometry. Do you understand this? All right? So why is there a need to switch to moles? Why can't we just work with grams? Can you switch to your notes page? Why can't we have grams of A? Why can't I tell you how many grams of B it will make? Why do I have to switch it into moles? Let's look at this balanced equation. If you have 2 grams of A, 1 gram of oxygen, and in your balanced equation, if the coefficients denote grams, does it make sense? 2 plus 1 is 3 equals 2. Does it make any sense? No. 3 grams is not equal to 2 grams. It disobeys the law of conservation of mass. Yes or no? So, it is very important that we convert them into what first? Into moles. Alright? So, this idea of being able to calculate via moles is what is called stoichiometry. So, let's go to the back sheet. Here is a reaction. Okay? So you can get asked different types of problems. Here is the first reaction. Iron reacts with oxygen to produce iron oxide. How many moles of oxygen are required to react with 1.3 moles of iron? Are they trying to relate oxygen to iron? Is that right? So how do we do this problem? First off, you need the equation. Iron. How do you write oxygen? O2. What is your formula for iron 2 oxide? Fe2O3. What is the next and most important step? We should balance the equation. Alright? So oxygen is a 2 and a 3. So I'm going to put a 2 there. I'm going to put a 3 there. And I'm going to put a 4 there. Okay? So if we start with 1.4 moles of iron and we need to find out moles of oxygen. Are you with me? What is first given to me? 1.34 moles of iron. Is that right? What do I cancel out of? Moles of iron. What am I trying to get into? Moles of oxygen. When I switch substances, where do I get my numbers from? From the balanced equation, the mole ratios. Is that right? What is my number before iron in this case? 4. What is my number before oxygen in this case? 3. And what is my math? 1.34 times 3 divided by 4. Now you'll look at this for your significant figures. What is your answer? Can a student give me the answer? What is it?
1.01 moles.
1.01 moles of oxygen. It's very important to write substances down now because you're changing substances. Does that make sense? Okay. So moles of iron and moles of iron will cancel. Is that right? It was a simple proportion problem. Let's do another reaction. All right? Here is a reaction. Calcium reacts with phosphoric acid to produce hydrogen gas and calcium phosphate. All right? The reaction is not balanced. So I need a 2 here. I'll try to balance my polyatomic ion first. That will be a 3, and the calcium is a 3. And that's a 1. Is my equation balanced? Okay? So let's look at the problem very carefully. What am I starting with? What am I starting with? The substance is calcium. Is that right? What of calcium am I starting with? Grams of calcium. What is the problem asking me to convert to? What is my substance? I'm going to calcium phosphate. What of calcium phosphate am I converting it into? Moles of calcium phosphate. Can you look at your mole map and find out from where to where you're going? Are you going from grams of A to moles of B? Are you seeing the strat? So what should gram A first be converted to? What should mole of A be converted to? Mole of B. Do we understand this? Okay? So how do we set up your tracks? You always start with the given number, which is 17.3, and it is grams of calcium. Is that right? What am I converting my grams of calcium into first? Moles of calcium. What do I write on top? Moles of calcium. What do I convert my moles of calcium into next? Moles of calcium phosphate. I'm converting it into moles of calcium phosphate. Right? Does anybody not understand this step? Are you with me as I do this? Okay? What do I need to cancel out of? Very good. So I need to find the molar mass of calcium, which is what? 40.08, right? Potassium is 39. You need to look at calcium. Calcium is 40. Potassium is 39.1. Right? So what is my number before mole? Is my substance changing? Is it calcium and calcium? Listen to this very, very, very carefully. Is it calcium in the bottom and calcium at the top? What is my number before mole? If the substance is not changing, what is my number before mole? 1. What did I just cancel out of? Grams of calcium. Is that right? What do I have to next cancel out of? What is in the numerator? Moles of calcium. Do I need to cancel out of moles of calcium? Right? Now let's look at the numbers as we fill them in. What is it in the denominator? What is it in the numerator? Calcium phosphate. When you're switching the substance, where do you get your numbers before mole from? From the balanced equation. That is your mole ratio. Is that right? What is the number before calcium? 3. What is the number before calcium phosphate? 1. So my multiple proportions, I set it up all as a track. And I can do the problem very quickly. Okay? And so my math will be 17.3 times 1 times 1. What do you do with numbers in the denominator, guys? The calculator is stupid, right? You need to either hit divided by every time you divide, or You need to make sure you put numbers in the bottom as a bracket. Can you put this in a calculator and tell me what the answer is? Yes, Jacob. 0.14? 0.1444 because it's three significant figures. 0.144 moles of calcium phosphate. Are we good? Do we understand that? Okay, let's do the last and final there is another problem, and in this case, what is it asking you to convert from? I can see it. What to what? We're going from moles to grams. Moles of what, guys? Moles of calcium? Alright. So in your mole map, you are starting at moles of A. Correct? Are you with me? Are you in mole A? What do you convert mole A into? What do you convert mole B into? Grams B. Do you see that? Are you going mole A, mole B, gram B? Okay? So I have 1.8 moles of calcium. What will I convert 1.8 moles of calcium into? What do I fill in the numerator? What am I converting moles of calcium into? Moles of phosphoric acid. Is that right? What am I converting moles of phosphoric acid into? Grams of phosphoric acid. Correct? What do I cancel out of? What is here? What do I cancel out of? Moles of calcium. What do I cancel out of? Moles of phosphoric acid. Are we good? Let's look at calcium is in the denominator, phosphoric acid is in the numerator. It's mole to mole. Where do I get my numbers from? Mole A to mole B. Where do I get my numbers from? So what is the number before calcium? 3. What is the number before phosphoric acid? 2. And then this is phosphoric acid and phosphoric acid. What is the number before mole? 1. And what is the molar mass of phosphoric acid? 98.0. And you should know to do the math. Is that right? What is the last problem asking you to go from? Grams of A to grams of? Do you think you can set it up? Alright? Why don't you try this and some practice problems for homework? You will have a quiz on writing dynamic equations next class.
Yeah. Do you have to, okay, so if I can...
Alright?